Hello and welcome to this video on determining the equation of a straight line. So you can see here in this question we've been given a couple of diagrams and we've been asked to find the gradient and the equation of each line. In particular, we've been asked to give our answer in the form y equals mx plus c. So let's just highlight that just now because the m and the c are both important features of these lines. The m there representing the gradient and the c representing what we call the y-intercept. That's the point where the line crosses the y-axis. Now, if we look at the first equation on the left, it's not too hard to identify the point at where the line crosses the y-axis. It crosses at -2. So when we go to write our equation for this line, we'll be able to replace plus c with -2. Now that's actually very similar for the other graph as well. As you can see, it crosses through the y-axis there at -3. So finding the y-intercept when you've been given a graph, a drawing of the graph, is usually not too bad, but it's working out the gradient that can sometimes be tricky. Now, both of these lines lean forward as we go from left to right along the x-axis. So they've both got the same type of orientation and they have positive gradients. So it's important to remember that lines that lean forward like this as you go left to right on the x-axis, they have positive gradients. And to calculate the gradient, we just need to find some points on the line that go through points on the graph paper, so some nice points on the line. So one way of doing that is just looking along the line until we find a point like this one, which we can clearly see crosses at the point 3, 0. And then if we carry on down the line, there is another one down here and it happens to be -0, -2. So we've got 2 points on the line that meet the graph paper. And the reason for doing that is because what we really want to be doing is counting boxes. We want to count how far down we go, that's the vertical, and we want to count how far across, this idea of horizontal. So that's 3 boxes horizontally and it was 2 boxes vertically. And the most important thing to remember here is that gradient is given by the vertical distance or the vertical change divided by the horizontal. So we can write that at the side here. M is the letter we use for gradient and it's given by vertical, which I'll put in orange there, divided by horizontal. So as long as we can count the boxes here and remember to divide vertical by horizontal, we should be okay. What's the equation of this line? Well, it's y equals, it'll all start like that. M is our gradient and our gradient is vertical over horizontal, which is 2/3 in this case. So 2/3. Don't forget x, it's very important, it has to be part of this equation. And plus c, well, we said right at the beginning that this graph crosses the y-axis at -2, so actually it's going to be -2 that we use there. And we can apply a lot of that thinking to this next example. So if we look at the graph of the one on the right hand side, try and find a good point. There's a couple there, and what we can do is count the boxes. So down here we're going down 2, that's our vertical, and then the horizontal in this case would be 1. So our gradient is 2/1 in this case, which is of course just 2. So the equation y equals always starts like that. Gradient of 2 this time, not 2/1, but actually just 2. Don't forget x, always has to be there. And then we need to add on the c value, which we saw earlier on was down here at -3. That's that y-intercept. So we've got time to look at a couple of other examples. And you'll notice these two are slightly different in that they lean backwards as you go from left to right. They're sort of sloping down the page as we go from left to right. So these have got negative gradients, and but we can work out everything else in the same way. So the y-intercept for the first one is there, crosses at 1. And then if we want to find some good points, we could use that y-intercept. We could use any good points that we can find. So we could use down here, that's 1, -1, and in here 2, -3. So any points will do. We want to count boxes down, so that's 2, and we want to count boxes horizontally. That's 1. So the gradient, remember, vertical divided by horizontal. Now this is a negative gradient because the line slopes backwards, so our overall gradient will be negative 2 over 1, which is of course just negative 2. So what are we calling this? Y equals gradient of negative 2. X must be there, don't forget that, it'll be no good without it. And then we've got our y-intercept of positive 1 this time, that's the green bit up here where the line crossed the y-axis. And then on to the very last one, let's see what we've got here. Well, very exciting, it crosses the y-axis at 0, so there will be no value that we need to add on at the end of this equation. What we need to try and do is determine the gradient, and the way to do that is to find any good point. So we could go here. That's a good point that we can read off easily, negative 2, 1, and we could take the origin, that's fine, 0, 0, and count the boxes. So down we go, 1 box down, and if we count horizontally here, you'll see it's 2 boxes horizontally. I've done it just above the x-axis there so we can see that's 2 boxes horizontally, 1 box vertically. Remember, gradient is vertical divided by a horizontal, so in this case y equals 1 over 2, but don't forget this was a negative gradient because the line was leaning backwards, it was heading down as we went from left to right, so we've got negative 1 over 2, negative a half, x always there, and then plus nothing because the y-intercept is at 0, so we wouldn't write anything, and that would be the end of that equation.